It's time to concentrate. We're going to talk about scaling ratios and part-to-part and part-to-whole ratios. Make sure you have your packet open to page 5 so you can complete the notes. In problem 1.2, you may have used the ratios below to determine which recipe was the most orangey. Below are two ratios describing mix A. One is 2 types of concentrate to 3 cups of water, which can be written as 2 to 3 or 2 over 3. Another ratio would be 2 cups of concentrate to 5 cups of juice, 2 to 5 or 2 over 5. So the first ratio is a part-to-part ratio. It compares one part, the water of the whole, the juice, to the other part, the concentrate. So again, 2 to 3, that's a part-to-part ratio. In this case, 2 cups of concentrate to 2 cups of water. The second ratio is a part-to-whole ratio. It compares one part, in this case the concentrate, to the whole, the juice. So now let's practice writing part-to-part ratios and part-to-whole ratios. So mix A is given for you here as an example. Again, you have 2 cups of concentrate to 3 cups of water. That's a 3 to 2 ratio. That's a part-to-part ratio. Over here you have 2 cups of concentrate to 5 total cups of juice. So again, we had to add those two pieces together, the 2 plus the 3, which then made the 5, to get the whole value to put with it. And then the last column here, I have part-to-whole ratios where I talk about the water to the juice. So instead of pulling out the value for the concentrate, I'm going to use the value for the water, which in this case is 3. So you'll notice that all these ratios start with 3, and they're being compared to the juice, so 3 to 5. So take a moment and see if you can figure out the other ratios for the other mixes, and then check your answers. For mix B, you should have 5 to 9, 5 over 9, 5 to 9. Part-to-whole ratio should be 5 to 14, 5 over 14, and 5 to 14. Part-to-whole for water should be 9 to 14, 9 over 14, and 9 to 14. For mix C, you should have 1 to 2, 1 over 2, and 1 to 2. For part-to-whole ratios, you should have 1 to 3, 1 over 3, and 1 to 3. And for water, you should have 2 to 3, 2 over 3, and 2 to 3. And the last one here, mix D, you have 3 to 5 for your part-to-part ratios, 3 over 5, 3 to 5. For part-to-whole, again, I'm adding my parts together. I'm starting with a concentrate, 3 to 8, 3 over 8, 3 to 8. And to compare the water, water was 5, so 5 to 8, 5 over 8, and 5 to 8. Scaling ratios is another comparison strategy that you can use to determine which juice is the most orangey. In fact, you might have used that strategy. So take a moment and see if you can write equivalent fractions, equivalent part-to-part ratios for mix A, B, C, and D. So see if you can find those missing values. So for mix A, you might have noticed across the top 2, 4, 6, 8, 10, 12. On the bottom, 3, 6, 9, 12, 15, 18. And you could have also built those up with scale factors. So you could think 2 times 2 is 4, 3 times 2 is 6, 2 times 3 is 6, 3 times 3 is 9. And you could have gone the whole way that way. Or you might just notice, again, that each one of these could be simplified to 2/3, and maybe you were able to build it up a different way. Now looking at mix B, along the top should go 5, 10, 15, 20, 25, 30. And the bottom should start with a 9, 18, 27, 36, 45, 54. So you're probably noticing here that each time I add a group of 5, I also add a group of 9. That's what preserves that 5 to 9 ratio and makes these all equivalent. Again, if you're not sure if something's equivalent, check with a scale factor. 9 times 4 makes 36. 5 times 4 makes 20. That tells me that it works since I used the same scale factor and found those values. Now looking at mix C, top value should be 1, 2, 3, 4, 5, 6. Bottom values were 2, 4, 6, 8, 10, 12. And mix D should have started with 3, 3, 6, 9, 12, 15, 18. Bottom values were 5, 10, 15, 20, 25, 30. Again, check for scale factors and look for ways to figure out how to scale those ratios up. Last thing we're going to do here is think about how can you use these ratios to compare mix A and mix B. So if you take a moment and look at mix A and mix B, see if you notice a ratio or ratios that you could compare easily. So you might have noticed 6/9 and 5/9. So in the case of A, 6/9 means I would add 6 cups of concentrate to 9 cups of water. For B, 5 cups of concentrate to 9 cups of water. I'm adding the same amount of water, but I'm adding different amounts of juice. And so since I'm adding more of the concentrate here, that tells me that A is going to be a greater oranginess than B. So this is just one way that you could compare what's there. You might have also noticed 12/18 and 10/18. Again, that has the same ratio, so 12/18 is also greater than 10/18. All right, that's it for scaling ratios. There's lots more to come when we see you for CS 1.3.